This little video is about data and business intelligence in the first lecture of two. Last class we talked about sustainable infrastructure and architecture, and there's a few more concepts I want to cover before we go into the data and business intelligence side. So we talked about what sustainability was. We went through the UN sustainability goals, and if we then turn our attention to how data centers and information systems impact sustainability. One of the concepts we talk about with sustainability in terms of IT and information systems would be cloud computing. Cloud computing is a centralized way of running computers instead of running them decentralized in small different units. We gather them together at one place, aggregate it, and in that sense have a lower carbon footprint. Cloud computing benefits, of course, include that it's accessible everywhere. We can save cost because we aggregate the different units. It's more flexible. We can access it. Normally, they are redundant, so if something breaks down, it still continues. Whereas if we have it on our location, if we have a breakdown, it might take us longer time to get up and running again. It's more reliable. It can be normally these cloud computing based systems, they can be accessed with all kinds of devices. We might have a system where we might not use certain types of devices in order to access with the data we are looking for. We have capacity on demand, which means that if we need more space or a little less space, we can actually change that on the fly, and much easier for us to do, much cheaper and quicker for us to do. Backup and recovery is also set up in larger setups, part of larger systems, more stable, and so the whole thing is more scalable. So that's some of the advantages of cloud computing. Core concepts with cloud computing would be a software as a service. We've covered it before. Basically, it is running a software instead of your computer on a computer over the internet where you use a browser to access it. You could also use a special app that's been produced that manages the connection between your laptop with a browser type of a setup in the app, and then interactions over the internet with the actual server that holds the software. That actually means, for instance, that if your computer doesn't have a lot, or server doesn't have a lot of power to calculate things, but you use a cloud to access the software, you can have access to very, very powerful computers that can calculate things quickly. So that's one of the advantages there. Virtual server, that is basically a server setup, so a management setup of your data that is accessible through the internet, for instance via a browser where the server is standing somewhere else, but you can still access the software on that server and manage the server remotely. Last little concept that's might be a little hard to understand if you haven't come across it before, has to do with a big data setup. So think about this. Let's say we don't just have tables, rows and columns with numbers and text. How about if we have a lot of photos or video streams and things like that? Well, we can't really store that in a relational database because it's not digitalized in the format that we're looking for. So in order to handle big data, first of all, we have much bigger amounts of data we don't need to cover, which might not be might not be able to say that on one server. We have to have multiple different servers, and in terms of capturing that data, we might have a difficulty of capturing ongoing data and adding continuous data coming to us into a static database. So in order to handle the big sets of data, companies, they use a system called Randrup, which is in essence an open source software framework that handles the storage of big data. Basically what it does is that it connects a network, a big network or cluster if you want, of hardware that can be located different places on the internet. So and then it splits up both the storage and the calculations on multiple different computer devices or hardware devices, which enables us to both store and handle and bring up and aggregate the large sets of data. So Randrup is a special type of a data setup for big quantities of data that we use when we have big data. The next theme I want to touch upon is sustainable data center. Sustainable data center, well, first of all, data center is basically a place where we store and handle our data. It's easy to think about as a physical location where we have different types of servers, and there is a communication network that enables us to both communicate with the servers on location, but also enables us to have access to the data servers that's in the data center remotely or via the internet. A sustainable data center is then a data center that runs in a sustainable way. We've already covered the goals of the UN sustainability, and when we then talk about a data center being sustainable, well, some of the effects that a data center has on the environment, on society, would be, for instance, the carbon emissions. So a sustainable data center, it reduces carbon emissions and energy consumption. So that's carbon dioxide, carbon monoxide that is produced by the machines that we run. And a data center can be sustainable if it reduces that carbon emission. We also work with reducing the required floor space, because if we less floor space, we use less materials, we use less energy, we use less maintenance cost in order to handle that space. So that's why a smaller space is more sustainable than a larger space. We also work with the choice of geographical locations to help sustainability. For instance, if a server park needs to be cooled, we can do that through, for instance, electricity that runs an air conditioner that brings down the temperature within the room where the servers are. However, if you place a data center in a cold location, it could be northern Norway, could be Alaska, then you don't need electricity to cool the air. You just need a ventilator that brings in air from the outside into the server room that then can cool the air through natural cooled air. So that's one way where location can help. We can also place our data centers next to sustainable energy sources. So for instance, if you place it near a solar cell park or a windmill park or a river where you have water energy coming, so those would also be locations that would be considered sustainable because it's just next to or adjacent to sustainable energy sources. Last area we work with is recycling and reuse of all our electronic waste. That is in terms of how we dispose and reuse materials. So many companies today, and including, for instance, our university, we are not discarding and throwing away our computers, used computers and other routers and other equipment. What we do is actually sell it on auctions for people that recycle it and take out the materials that's in a computer. It could be gold, silver, platinum, other types of materials, and reuse those materials. So that's a sustainable data center. Next theme is a little bit about a carbon footprint. So a carbon footprint is, of course, the emission of carbon dioxide and monoxide up into the environment, and there are many different sources for that. A carbon footprint will then be a little map about what things have an impact on the carbon footprint. So for instance, recycling has an impact, how we handle waste, our transportation, how we transport things, the use of electricity, cars and transportation, gas consumption, emissions from different machines and other factors all have an impact on the carbon footprint. If we look at carbon emissions, there are a number of statistics published, and you can easily find them online. I picked out a couple of them. So if we look at carbon emissions per capita, you can see that the U.S. is one of the world's largest emitters of carbon dioxide, whereas a country like United Kingdom has a lot less. And from my background is from Scandinavia, and we are a location, at least in the Western world, that has very low carbon emissions per capita. However, We are not the most effective ones. As you can see, some of these developing countries like Chad, Rwanda, Uganda, and Somalia, they have very, very low CO2 emissions. If we look at the total emissions that's released into the environment, then that takes into account the size of the different locations. You can see on this map that on a worldwide scale, China and the United States are the two countries that emit the most carbon dioxide. And then you can see a number of the other countries. For instance, Russia has much smaller emissions. India is also quite small in relationship to the amount of people they have. So that's the scope of the carbon emissions, and that's what we work with one of the things we work with when we work with sustainable data centers. There's a good case story about a company. Or many companies have these case stories today because they try to explain how green they are. One of the interesting stories I found and I wanted to share with you is a story about Google and one of their data centers. So what did they do to try to make it more sustainable? Well, they used a number of different techniques. So first of all, they had a data center where they added temperature monitoring, so they can control the temperature. And they can use those controls to understand how air needs to circulate in order to bring down the amount of energy used to cool the servers. They optimized the air vent tiles about how they operated. They actually found out that they didn't need to have, for instance, 70 degrees or 65 degrees in the room. The computers could just as well run around 80 or 81 degrees, so they increased the temperature to 81 degrees so they didn't have to heat it so much. They also turned off the humidity settings in terms of how much humidity was in there, so they were running with lower humidity that was actually necessary. They also built up a special system for how to block off the ends of the cold aisles with curtains, so they reduced the space where the cold air was that were supposed to cool the servers. And they added some control mechanisms, and by doing these different things, they got a return on investment of this, the sustainability measurements at 2.68. They lowered the energy usage by almost 40%, and in this data center they saved 670 million watt hours. So that's just one story about how a data center can work with being sustainable. What you might also find interesting is that there are some data centers that are 100% sustainable. The one that's run by Verne Global in Iceland. They use 100% geothermal and hydroelectric, so that is water energy, in order to run their data center. Apple, they have data centers that are 100% renewable as well, and they have had a policy about that for many years. And their first data centers became 100% using renewable energy in 2013. And all Apple, they became they ran with renewable energy in 2018. Google also had a policy of 100% renewable energy, carbon neutral, and they reached that goal in 2017. And then, of course, there are other places that have similar sustainable data centers. One is Other World Computing in Illinois. They use wind power, geothermal, and solar in order to power the data center. And they also do water recycling and water conservation in order to become more sustainable. So, a couple of examples of sustainable data centers. So let's get into the main theme of this lecture, which is about data and business intelligence. So, you probably already studied the book. You have basic understanding of what we are talking about. So let's test the current understanding you have by asking 6 different questions, which basically cover some of the core concepts of this theme. So first of all, think about this question number 1. What are the 4 primary traits that determine the value of information? So what can determine that? So try to think about it. What comes to mind? Well, when you think about it, maybe if you even look in your notes, you will see that the 4 different types we're talking about is the information type, which basically is if it is transactional or it's analytical. It's timeliness. It is quality, so it's if it's good data or bad data. And then it's the governance of the value of the information, which is basically done through processes and procedures. Next question. What is a database? Well, you probably know it. You're probably working on it if you're working on the Access assignment. Basically, database is defined as an information storage of different types of objects, events, people, and places. So storage of data, and data is typically called either objects, events, peoples, or places. That's the type of information that the database is stored. In other words, it's basically a library of different kinds of contents. So a library is a physical storage of information, where a computer would be a digital storage of information. But both of them are storages of data in a physical or digital form, of both. Question number 3. Database management system. What is that? Well, it should be pretty obvious. If a database is storage of information, then the database management system is a system that can manage the database, which basically means to create, read, update, delete data in a database to control the access and the security. So that would be the management system. Examples of management systems would be Excel, that's the software. The Access could be MySQL or SQL Server, it could be Oracle. All of these are examples of software with database functionality. Question number 4. Relational database model. What is that? Well, relational database we already talked about. So that is a database that stores things in basically 2-dimensional columns and rows. Now, the model about a relational database is basically is how the data are related. So basically, a relational database model, it stores information in 2 dimensions in a logically put together model. A model is then a map or relationships, how you picture the relationships, how you illustrate the relationships between the different types of data that you have in a relational database. Question number 5. Business advantage of relational databases. Well, of course, there are many types of business advantages, but the ones we're more interested in, and also the definitions we have in our textbook, talks about that it increases our flexibility, it increases scalability and performance, it gives us information integrity, security, and it is less redundant. It gives us less redundancy. So that's the standardized business advantage. Read more about that in the book, but that's the type of advantages we're talking about. Last but not least, question 6, business benefits of a data-driven website. Again, there are a number of different benefits of having a data-driven website. The one we're specifically after when we talk about it here will be that a dynamic website, which is a data-driven website, gives a richer type of experience. It can be tailor-made to different users. It is more relevant to the user, if it's a customer, for instance, and it can hold up-to-date information for the users of the website. It's one of the major ones. Besides that, we also talk about that it's easy to access the data using a web browser versus another type of system. Web browsers are usually very intuitive and easy to use versus other types of software systems. It's easy to manage the content in the database. It can store large amounts of data for the website when it's based on database links. And it also can eliminate human error for updating and showing different kinds of information when it's automatically linked from a database to a website. So that's some of the core concepts. Now, what I want to look at now and give you a little insight into are some of the some examples on relational databases and other things that we talk about. So first of all, let's take a look at what actually a relational database is and how we define it. Benefit is you probably worked on Access already, so you can relate this to your experience. I'm sure you can also relate that to your Excel experiences. But let's first of all take a look at a relational database. Relational database basically holds multiple tables, or a worksheet if you work in Excel. And what makes it relational is that there's a link between these worksheets. The link comes in identifiers, or we normally also call them keys. And a database typically have a primary key, so that's the primary organization that links different tables together. So the visual you see on your screen now, you can actually see that the primary keys that are used for a database, and this is a database for music storage, is, for instance, a track number. It could also be a musician number. So those ones would be primary keys that different tables are using, so we can link the different tables together. If there were no keys that were similar, then the different tables would not be linked together. And if they're not linked together, so if they don't share at least one column that has the same type of information, then we cannot relate them to each other. So basically that is the definition of a relational database, and this is what it looks like for a specific database. Next concept I want to share with you is a little more on the mega level, or the conceptual level in terms of a company. So if you want to look at what type of information runs around in a company, we normally talk about, first of all, the different information levels. I don't know if you remember that from one of the first lectures I did, but then I talked to you about that we use data and software on an individual level, on a group or departmental level, or an enterprise level. So that's the first level of the data overview triangle. The second level, we talk about information format. So that's what types of information we actually have. What format do they come in? Do they come in documentations, presentations, spreadsheets, data in a database? What type of information are we talking about? And then the last level in the organizational information overview is the information granularity, and that depends on if we are looking at very granular data, which is the fine levels, the detail level, or how aggregate we look at the data. The aggregate levels of data is typically for management. So where we want to aggregate the sales, to look at the sales for December or January, and aggregating, we want to compare sales from our company with other companies, so we use an aggregation of our data on a pretty high level. We might also want to look at what we sold in one store that one representative of ours, one of our sales representatives were responsible for on a Tuesday morning for one product. That would be a fine detail level, still a little aggregated, but on a much more granular level. So that's the types of information discussions we typically have when we talk about what information perspectives we have on information. Now, we talked a little bit about transactional and analytical information. So, and it's important to understand the differences here, because the transactional information are basically information that's generated by different type of things that we do in a company. So it could be, an airline ticket that we generate, it could be a sales receipt that we have, it could be a package slip. So all of these are information sources of things that we do as part of our operation. All of this data that goes into a database, and then we have analytical capabilities to bring out that information in different types of views. So for instance, based on sales receipts and package slips, we can start producing, for instance, product statistics. We could do sales projections, and we can look at trends and so forth. So basically a database also enables us to aggregate or to access the data in certain aggregations or certain views that gives us an opportunity to analyze with the purpose that we might have for using the database. So basically, we can talk about source information, which is typically transactional information coming from our operations. And then we talk about intelligent information or analytical information, where we select, aggregate, and analyze the data to find out certain types of information in an aggregate form that helps inform the decisions that we might do in a company. Another concept that you probably heard about, and if you haven't seen what it is before, I want to make sure that you understand what it is. A data warehouse. Because normally, if you work for a company, you go to a data warehouse if you need data to analyze something. You don't go to normally the database. So the data warehouse is a system that's set up for you to access the information you need in a certain format. So in this case, and you can see it in this illustration, we might have a set of internal and external databases that are linked to a data warehouse. This link in the data warehouse is built through the structure of the data warehouse. So the data warehouse has some conventions about what type of information it has, and it links the different data from different databases into the areas that we need. For instance, if you work in a marketing department, you want marketing information. So a data warehouse might group different types of information from different internal and external databases into a marketing information center. The same thing if you work with production or logistics, you might want to have an inventory information, and so a data warehouse can build together the different types of information that's relevant for inventory management, and the same thing for sales and billings and competitor information and so forth. Now, once you have grouped and selected the different types of relevant information and linked the databases to these ones, then the data warehouse will continuously be updated with a selection of data that's relevant for certain type of use. Now, then if you come, for instance, from the marketing department, then you can actually access the data warehouse and ask for let's say, a marketing data report, or there might be many types of marketing data reports depending on what type of information we have. So we access a marketing data mart that is produced by the data warehouse, and that's where we look for the information we normally use for managing marketing, and the same thing for production inventory and for sales and so forth. So that would be a data warehouse. So that is a system that sits in between the databases, so the raw data, and you as a user that needs to analyze the data. So the data warehouse gives you access in one place to all the types of information that you have within a company. A little concept that you might have seen is ETL. ETL is basically defined as extract, transform, and load. So that is how something is taken out. It's basically the data logistics, right? So how do you get the data from one place to another place? And I've deliberately chosen another model to show you where you can actually see a data setup. So for instance, a data sources for a company could be from the ERP database. So that's typically their purchasing, invoicing data. You could have another financial data from a system. You can have CRM data. That's typically, it's called customer relationship management data. So that's typically what's linked into the sales department. You have HR data. That's data about human resources. So basically personnel, recruiting, employees in a company. Then we have other types of data, legacy data from other systems and stuff. I don't want to bore you with what that is, but that's the basic databases and data sources that we have. They are then transformed and put into a data acquisition setup, and these are then put into a data warehouse where we integrate and make sure that the data is connected. And the next thing is that we make them connected in such a way that you can also search for different types of data and extract that from the integration layer. And once you can manipulate the data in the application layer, then we're able to produce different types of reports that the user might have. So a process of analytics based on a database system setup and a data warehouse would be that, let's say you're a marketing manager. You want to understand what of your Google ads have been the most effective during the last week. So that would be the reports you were asking for. So you're asking for all the banners you run, how many views they've had, and how many clicks they've had. So that would be your report layer. Then the report, when you ask for that, goes into your application data that then tries to find data from the integration layer to give you those reports. The integration layer pulls the data from the different types of databases that holds that specific data. So you might have one database where you have a list and overview of the different types of banners you run. You might have an external database, so for instance clicks, that might reside on a Google database, external database. So the integration layer pulls the data from the different data acquisition points, that pulls them from the different data sources. So that is like a blown off map of how the data path is from once you want some data to how it gets to in your hands. So that's from the database up until it comes into your hand. So data process, or in this case we call it an ETL process. When we work with big data, we have a similar process, but instead, and this is a little map of that, so instead of having relational databases, we have, for instance, the Randrup setup that is in the middle. You can see that when it says SQL and a line over, that's non-SQL. So that is where the big data network sets in, and that's the network that manages all that data. Otherwise, it is pretty much similar to the other traditional flow. So it's basically just a little bit of a different setup for how you handle the actual data management and data transportation. A data center or data management, of course, also have a security level. And when we talk about database security, we're basically talking about three different things. You are already using these security measurements, so I think you're pretty comfortable with them. Basically, in order to access a database, you will need a password, a username and password that provides authentication that you actually allowed to go in and look at certain parts of the data. Besides that, we also manage access levels. So we might have access level A, B, C, and D. A is very restricted access, could be for guests. B level, you can do a little more things. C level, you can do even more. And the ultimate level of access would be, for instance, administration rights. So if you have a laptop or a computer at home, when you have administration rights, you have full access to everything that it does. In a database, we can actually set up different levels of security for different types of roles or different types of users. And then, of course, we also have an access control system that manages the access control. So basically, the security features of database setup would be a password, access level, and access control. So not something out of the ordinary. One of the biggest problems we have with databases is, of course, the quality of the data. So when we talk about a good database, we talk about a database that has good data, that is clean, and is ready for use. When we have a database that's dirty, that's when we get inconsistent data. We can't rely on the data, can't believe in them, and that's a big problem. So good data, what is good data? Well, we talk about it in terms of 5 key traits. So first of all, to be good, data needs to be accurate. It needs to be complete. You need to have access to all the relevant data. It needs to be consistent. So if you run on a query today, query tomorrow about the same thing, you should get the same results. It's timely, so you need to get it in time for when you need it. You don't have to wait for it a lot longer than you can handle. And then it has to be unique, which means that each transaction or event, they're represented only once in an information, so we don't have unintended duplications in a database. So those are the things that we normally work with in order to secure that the data in a database is good. Now, the data is there for a reason, and that's, of course, to inform our business in order for us to do better decision making and run our operations smoother. So what we normally talk about on top of the data is, of course, an intelligence part. The analytics, data analytics, is used to give us some intelligence that we can use in our business operations. So questions that might be relevant for use of data could be some of these ones that I'm showing you on the screen here. So, for instance, we might have a question about why sales are below target. And then a database answer would be about why or where we see sales that are lower than the targets, because we might have a national sales target, but it might not be all regions in the country that are below target. And in this case, it's not. This analysis will show that we sold less in the Western region, and that is mainly why we are below the sales target. Then we can ask questions about that. Why did we sell less in the West? Well, because sales of product X dropped in the period we're looking at. So it's not just general sales, it's dropped, mainly sales of one product dropped significantly. We can ask why that dropped, and then we can go in and look at the reasons why the sales of one product dropped. We can see, for instance, that customer complaints increased. That impacted the amount of products bought from different customers. And then we can ask ourselves, why did the customer complaints increase? And the reason for that might be because of late deliveries, or at least they went up by 60%. All of these questions are then different types of business questions that business analytics can provide answers for using different types of data from our data warehouse. Data warehouse pulls it from the databases that we have. So that again illustrates the link of what we can do. Also illustrates an example of a business intelligence session. Basically, it's questions and answers based on the data that you have for certain business reasons. Coming back to big data, I want to show you a little map of the key characteristics of big data. So if you want to have an overview of or definition of what big data is all about, you can talk about variety, veracity, volume, and velocity. Those are the conceptual descriptions that I also use when someone asks me about what big data is all about. Basically, big data is variety, many different forms of data, not just text and numbers, other things as well, pictures, videos, audio. It has a high veracity. So that means that it can come in different quality levels. So it's not all unique. It could come in duplications and all that stuff. It is of high volume, so large amounts of data. We are talking multiple terabytes of data normally. I think I was asked about a half a year ago, so how much is big data? I would usually say it's 2 terabytes or more. That I would say is big data. But there are many different ways of defining a large amount of data, and in a year or 2 years it might be much more than that. But that's the level we're talking about today. And then we talk about velocity. So that means a continuous flow of data. Remember this: if you work with Excel, you basically have a static set of data, right? So you've got the data in, they're right there, and no one's adding to them every second, right? However, with big data, we might have data coming in all the time and a lot of data every second. So once you talk about analytics and you want to analyze a set of data, then what data are you using? So basically, when we talk about big data, we are talking about how do we actually handle what slice of the data are we actually taking out and grabbing for analysis. And then we can also talk about the dynamic analytical system. So we can set up an analysis to run continuously where we get results every second on, for instance, sales or users or whatever we want. But that has to be linked to this dynamic high flow of data. So basically, big data is all about variety, veracity, volume, and velocity. You also have probably read a little bit about data mining in the textbook, and I want to cover a couple of the concepts about data mining. Basically, data mining is the process by which we use data. And so it's a decision-making process, if you want, that basically starts with understanding the business needs. So, what is the business and what type of intelligence do we need from the data that can help our business? So we normally talk about business understanding being defined as different questions we want to have answers to. Now, in order to answer those questions, we have to understand the data that we have. Where do we have it, and what forms do we have it, and what type of data from where do we need to extract in order to be able to answer the question. Then we talk about data preparation, so getting the data out and preparing. It could be a cleanup if it's unclean data, if it's faulty data, if it's redundant data, so data that's not unique. Then we have to prepare the data for the analysis. And then once the data is ready for analysis, then we do data modeling or data analytics in order to extract the answers for the questions we have. Once we have pulled out the, let's say we use the analytical software to find different statistical results, then we evaluate the statistical results in order to give the actual answer to the business question. And then once we've done an evaluation, there might be a recommendation, or there might be an action point taken based on the answer that we give to the business question that we have. And in order to do that, that all revolves and uses data, but it also uses software and other things. So that would be a data mining model or a decision-making model where data is used as the core. And what you see here is the textbook version. However, when I work with companies, we usually use an extended model for how we use data for business reasons. So take a look at this little map here. Again, it starts at the same place. We need to understand the challenge that the business have, so the reasons why they want some insights from some data. Then normally based on a question or information need of C-level people or other managers, we then plan the assignment. We look at, all right, so how do we produce those answers? So that's basically a project planning phase. We engage in order to see what is needed, when is things needed, what actions do we need to take, what do we do first, and so forth. So it's basically a little project planning or analytical project planning phase. Number 3 has to do with data needs, availability, and understanding. Again, this is about understanding what type of data we actually have access to. And if you work for a larger company, you might not have an overview of what type of data you have. So you first of all need to figure out what type of data do we have, where does it reside, what do we have access to, different locations. Once you have an idea of what you have, then you need to, if you've chosen the data you need to use for answering the questions, then you need to localize where it is, and you need to access the data. So this is basically a search and discovery phase of getting access to the right data. This might involve, let's say you have a laptop and you don't have the right software. That might involve getting to use another computer or virtualized software in order to access the data. And then, of course, you need to extract it, and you need to store it somewhere. So if you ask for a query, if you ask for a report from a data warehouse, you need to do that and store that extract of the data that you need to analyze the question that the business has. So once you've extracted the data and stored it, you need to prepare it and clean it up so it can be used for analytics, as we talked about before. Then you do your data modeling and analysis. So this is where you perform the different types of statistical analysis, for instance, or just basically it could be averages of basic stuff in order to answer the questions you need. Then based on the statistical software, you look at the results you get out of the statistical results and you transform that into business conclusions. Those business conclusions then feed into the decision making about the challenge that a business might have. So the business takes some decision based on the data that is provided, and then they execute and deploy the decision, and then based on that they actually go back and control whether the business challenge is solved or not, or to what extent it is solved, and if more things needs to be done in order to become even better or solving other business challenges. So that's the same type of circle, just have a little bigger granularity of the steps that are normally taken when we do business data analytics, data mining if you want, same type of terms that kind of mean the same thing. There are of course different ways to do data mining, and there are different types of analytics we can do. And our textbook shows just 4 standard ways. That is probably pretty good overview of different types of groups of analytics that we can do. So let's briefly just go through them to understand what they are. We talk about an estimation analysis. Basically, that is needed when we want to forecast or make a prognosis about the future. So let's say we need to forecast the sales for the next quarter. That would be a typical estimation analysis where we look at how the sales have developed now, and then we try to predict where it will go in the near future. We can also do an affinity grouping analysis. And that's basically look at what type of relationships there are between different variables. That, for instance, is we use when we want to understand what causes something else. So we can do a causal analysis, or at least a correlation analysis to see what things vary together. So that would be, for instance, profiling. So we could look at, if sales is impacted by weather, if sales is impacted by number of visits in a store. So what type of relationships are there between different things. Third area is cluster analysis. Cluster analysis is very, very useful when you do analysis of very large data sets, because you can see patterns in them. So let's say you have 2 million people that's been purchasing products from you within the last week. Or what type of people are these? So you can use a cluster analysis to figure out that there are 4 or 5 major profiles of different types of target groups or customers that are purchasing from you. The last one is the classification analysis. Basically, it's an organizational type of analysis where you categorize different data. So it's basically figuring out what something is and putting it into a box. So there you have it, the 4 standard types of data mining techniques that are used by companies. Data visualization is also a very fancy concept that basically covers the illustration of data. So data visualization basically means how to visualize what the data is telling you. The normal ways to visualize things would be with graphs of some sort. It could be a line graph or stacked bar charts. It could be a pie chart or something like that. I've taken up a few little more advanced ones here, so you can see that data visualizations is basically any type of visualizations of what the data is actually talking about in order to be more or easily consumable than a text table with different numbers in it. If we talk about business intelligence, and that's a huge area on its own, again, business intelligence can be a full semester course as well. But overall, to get an overview of what it is, and that's what we do here with the principles of information systems. If you want to have an overview, I think there are 5 traits you need to just to keep reminding yourself of. So first of all, business intelligence, the roles and purposes of the data warehouse or marts involve 3 different things. It involves having a data mart, which is a logical collection aggregation of data we already covered. It involves data cleaning, so basically standardizing the information so we can actually use it, so it's in a form that's ready for analysis. And then we talk about intelligence. That's where we try to extract the insights from the information that we have to support different types of business decisions. So roles and purposes of the data warehouse would be having a data mart, a location for the data, clean the data, and use it for business intelligence reasons. The advantages of business intelligence for decision making is I think it's self-explanatory. If you want to use data or do data-driven decision making based on facts, then that's what we do, and that we do that every day in all businesses. So basically what business intelligence does for us is provides us the ability to make better decisions based on different data sets and quantitative and analytics in different forms. Third characteristics would be the 4 characteristics of big data. So business intelligence deals with big data. I just covered the 4 different ones, so you already know them: variety, veracity, volume, and velocity. Data mining is also a business intelligence theme. We already covered that. It has to do with getting the data, finding the insights in the data, and deploying those insights in the business. And I showed you the different process model before. Last but not least, the importance of data analytics and visualization is great, because once you try to extract insights from data, once you want to present it to other people, if you show them a text table with 50 columns and 100 rows, people don't get it. You can't really show what you want to show. So that's why we produce different types of visualizations of the data we have to be able to tell the story that we need based on the data. So there you have it. That's the core themes that we have and revolve within the area of business and intelligence. So, enough about this part. Next time when you come to class, we will be talking about an exercise about how to handle the missing data in the data sets, because many times when we work with information systems, we want to do business intelligence, the data is not good enough for us to analyze on, and that's a big problem. So the exercise in next class will be about how you do that, so that's why I'd like you guys to bring your computer to a class. We will use Excel, not Access, so bring a computer with access to Excel. I will provide you with an Excel file, and we'll do an exercise about how you actually clean up a data set from a company. There you have it. So hope you've enjoyed this little video, and I will see you